Have you ever pondered about the enigma that blazes in our sky, the sun? Our own star, a fiery ball of gas and plasma, holds immense power and countless mysteries. This celestial body is not just a bright light in the sky or a source of heat on a summer day, it's a powerhouse, the heart of our solar system, creating gravity that keeps us in a steady orbit. Yet it also influences us in more intricate ways. It gives us daylight, drives weather patterns, and even shapes our very biological rhythms. But beyond these familiar roles, the sun hides secrets that continue to baffle us. It's a cosmic laboratory, a place where nuclear fusion happens on an unimaginable scale, where the laws of physics are pushed to their limits. But what happens when the sun gets a little too active? That's when we encounter solar flares. Solar flares, what are they exactly? Well, imagine the energy of millions of 100 megaton hydrogen bombs exploding simultaneously. That's a solar flare for you. Solar flares are tremendous eruptions of energy that occur on the surface of the sun. They are a fascinating yet volatile spectacle of our solar system's central star. Let's delve a little deeper. The sun, a colossal sphere of hot plasma, is fueled by nuclear fusion that happens deep within its core. This process generates an immense amount of energy, causing charged particles to move around rapidly, creating a magnetic field. Over time, this magnetic field becomes twisted and tangled, and when the tension becomes too great, it snaps and rearranges itself, releasing a massive amount of energy into space. This sudden, violent release of energy is what we know as a solar flare. Now you might be wondering, how much energy are we talking about? Well, a single solar flare can release the equivalent energy of over 1 billion megatons of TNT. To put that into perspective, that's over 10 million times the energy released by the Hiroshima atomic bomb. Yet despite their immense power, predicting when and where these solar flares will occur remains a challenge. The sun's magnetic field is complex and constantly changing, making it difficult to predict with precision. It's a bit like trying to predict the exact moment a boiling pot of water will produce a bubble. We know it will happen, we just don't know when or where. But here's the thing, these solar flares don't just stay near the sun, they have a far-reaching impact. Their effects ripple across the solar system, influencing not just our space weather but also our daily lives, from the functioning of our satellites to the electrical grids on Earth, but more on that later. For now, remember this. These powerful solar flares don't just stay near the sun, they have far-reaching effects. Solar flares dramatically alter the space weather, but what does that mean? Well, let's dive right in. Space weather isn't about whether you'll need an umbrella or a sun hat. Rather, it's the state of our space environment, influenced heavily by the sun's activity. Just as we have weather patterns here on Earth, space has its own weather systems, driven by the forces of our nearest star. Now, solar flares play a significant role in shaping space weather. These gigantic bursts of radiation erupt from the sun's surface, sending charged particles hurtling into space. When these particles reach Earth, they interact with our planet's magnetic field, leading to what we call geomagnetic storms. These storms can be mild, causing beautiful displays of auroras or northern lights, but they can also be severe, leading to something known as a solar radiation storm. Imagine a downpour, but instead of water, it's high-energy particles from the sun. Sounds intense, right? These storms have real-world implications. They can disrupt our satellite operations, affecting everything from weather forecasting to GPS navigation. Communication systems can go haywire, causing radio blackouts. It's like a cosmic game of dominoes. One solar flare can set off a chain reaction, affecting various aspects of our technologically dependent lives. And let's not forget the brave astronauts in space. They're on the front lines, directly exposed to these solar radiation storms. While spacecraft are designed to protect them, extreme space weather conditions can still pose significant risks. But as we continue to explore and understand the cosmos, we're getting better at predicting and mitigating the impact of these solar events. We're learning to dance with the sun, so to speak, navigating its fiery moods and temperamental outbursts. But it's not just space that feels the effects of solar flares. Here on Earth, we can feel them too. So as we look up at the sky, let's remember that our sun, while a source of life, is also a force to be reckoned with. Solar flares might seem like far-off phenomena, but their impact reaches our very homes. These eruptions of high-energy radiation from the sun's surface send shockwaves through our solar system, reaching as far as our own planet. When these solar flares reach Earth, they interact with our planet's magnetic field, causing disruptions in our atmosphere. You might not realize it, but these disruptions can have profound effects on our daily lives. For instance, they can interfere with our communication networks. The next time your cell phone signal drops, or your internet connection seems unusually slow, It might just be due to a solar flare. But it's not just our internet that's at stake. These solar flares can also cause power grid failures. Imagine for a moment an entire city losing power, all because of a burst of energy millions of miles away. It's a sobering thought, isn't it? On a lighter note, the interaction between solar flares and our atmosphere can also lead to a more visually stunning phenomenon: the northern and southern lights. Yes, those mesmerizing lights dancing in the sky owe their brilliance to solar flares. When a particularly strong solar flare occurs, these lights can become even more intense, filling the sky with an unforgettable spectacle of color. But we're not helpless in the face of these solar events. Scientists are working tirelessly to study solar flares, to better predict their occurrences, and to minimize their potential damage. With every flare that we observe and analyze, we get one step closer to understanding our sun's hidden secrets. So the next time you look up at the sun, remember the immense power it holds, and the mysteries it still keeps from us, and how closely our lives are intertwined with this fiery celestial being. Remember that each solar flare, each burst of energy, is a silent connection between us and our sun, reminding us of our place in the vast cosmos.